Lunar dust is interesting stuff. It turns out that there's some really kind of cool research done on a problem that was revealed during the Apollo program that didn't get a lot of press at the time. And here's how this works. A combination of practically no atmosphere. Technically, there is a little tiny bit of atmosphere on the moon, but it's like a quarter inch from the surface and doesn't count for much. Solar wind, which is electrically charged particles moving at very fast speeds, hits everything in the solar system, including the moon. And the moon doesn't have much of a magnetosphere. It doesn't have any atmosphere to worry about. And so what is affected? It turns out that nanoparticles of silicon that are known to have iron and oxygen attached to them are affected by this static charge. But there's an interesting couple of caveats on these. This is really interesting stuff. The Apollo astronauts had a big problem with these things. It was a big problem. There's lots of health issues, wear and tear on the cloth for the spacesuits. There's a lot of issues. For a mechanic, every problem is its own solution. And it's beautiful. It's beautiful. It's beautiful. Okay, so here's the thing. In craters where you have a dark section and the solar wind is coming across the crater, you get a differentiation going on. Go look it up, study it. It's interesting. Now, it turns out that it's possible, theoretically, and we need in situ, that is in place, studies to be done. Artemis, we're talking to you, the turtles, God bless you, where part of the solar wind skips the crater, goes over it. And part of that material, part of those electrons or whatever, forgive me, I'm slightly drunk. I've been drinking. It's okay. It goes down into the crater. And wherever there is a difference of potential, that's a battery. That's something you can draw electricity off of. We can theoretically make electricity just from solar wind in the dark. Remember that part. Okay. Now, there's some material science cool stuff happening where spacesuit cloth has been woven with electrically conductive material and charged with a electrical pattern of influence that causes those little dust particles to go away. It pushes them away. Now, if you can push something, if you can push a material, you can collect it. Now, here's a really interesting bit about the 3D printing. Size consistency is valuable. If you have a material of a consistent type, say silicon, we like silicon, right? That is very small and very consistent and doesn't have a lot of other contaminants in it, then we can 3D print with it. Now, the dust on the moon is known for lifting up off of the surface of the moon. And we can move it around with electricity, which means we can capture it. We can grab it. We can grab it. Okay. Now, small particle size in mechanical chemistry is important, and in electrochemistry is important because it means there's a lot of surface area. In mining, one of the first steps, besides conveyance, is crushing. Right? Because if you crush the stones into smaller pieces, you can expose more of the surface of the material to chemistry and processes. So this is where this dust comes in handy. The dust doesn't lift off the surface of the moon unless it's very small particles. So these very small particles we can collect electrically. And there's a component of it that I imagine we can use Venturi systems as a part of a cycling system to draw this material into a controlled environment where we can process it. And what I imagine is washing it with hydrochloric acid or other acids as needed to draw off materials like aluminum or iron. Now, iron is known for being in the lunar dust, that these little tiny particles of silica have a little bit of iron attached to them. We like iron. Iron's handy. We make all kinds of stuff out of iron. So we wash the iron off of this silica dust. It's micron size, very, very tiny. And then we wash it with distilled water, which isn't wasting water. We'll get the water back. We freeze dry it, and then we have beautiful powder that's very clean, high silica content, not much else in it. Now heating it will drive off a little bit of oxygen, argon, whatever that might trapped gases that might be in it, and we can collect those too. And thus making 3D printed objects handy dandy for a moon base. This is Darren Marchant, formerly known as the American Nomad News, and now the Astroponicist. Have an awesome day.